Hello and welcome. In this presentation, I'll be discussing process considerations in lean systems. The first process consideration that we have to think about is the pull method of workflow. It's essentially a method in which the customer demand activates the production of a service or an item. Unlike a push method of workflow in which you take a customer demand forecast and then production begins in advance of actual customer needs, in pull method you wait for the customer demand to actually manifest and then the production has to start, and this has many advantages in terms of reducing inventories in the system, reducing lead times, ensuring that the process flow is consistent with the demand rate, and all those then help organization to maintain their lean systems as well as improve overall quality of outputs. The second process consideration is the quality at the source. And the idea is that instead of inspecting quality of a product after everything has been produced, ideally what should be done is that the quality should be ensured while the product is being manufactured. So the worker who is responsible for producing a product should be also responsible for the quality of that product. And within this, we have certain techniques, approaches that help in ensuring that the quality is maintained while the production is going on. The first one is what we call jidoka. It's again a Japanese term which refers to automatically stopping the process when something is wrong. So once production is going on and one worker realizes that something is not working well, then instead of continuing the production, that process should stop. And first, that problem should be fixed on the line, and then the process should begin. So this is the idea of jidoka. Associated with that, we have technological innovations like and-on switches, where a switch in an assembly line allows that entire line to stop, and therefore all the workers can come to that place where there is a quality issue, and that can be resolved before everybody goes back and continues their production activity. The second technique which helps in quality at the source is Bukayoke, which is mistake proofing methods that are aimed at designing fail-safe systems. So here, for example, if a company manufactures a product which has modular components, then a way to ensure there is Bukayoke within that system, which again is a Japanese term for mistake proofing, is to ensure that there is only one way in which these modules can be put together, so that when the workers are trying to uh, bring these two modules together, they just have a standardized way of doing it, and the chances of error reduces as you reduce the variability of bringing these components together. The other thing which you also could be doing is mistake proofing by ensuring that similar kind of processes are being undertaken in the services sector. So once again, if similar kind of services are being done and there is a standardization on that front, then there is again a way in which you can mistake proof the system. The third process consideration is uniform workstation loads. And the idea is that lean systems work best when different workstations have similar loads on them. Or in other words, they have to spend almost equal amount of time, approximately equal amount of time on a given process. And if we can ensure that, then that case, we end up creating a system which is more likely a lean system. Again, we have several tools and techniques that help with ensuring a uniform workload on different workstations. The first one is what we call a takt time. Again, a German term here, which takt is a German term which refers to the beat at which the entire operation should run. And what we want is to determine what that should be, and then ensure that all these different workstations are all working approximately around that beat. Heijunka is a Japanese term which refers to sequencing of tasks. And in this, what organizations are trying to do is to ensure that they are able to create a uniform workstation load. And to do so, they can schedule or sequence the task on these workstations in a certain way. And that helps in turn in ensuring that the system is lean. And the third is mixed model assembly, which is when a company is making multiple products, then instead of making each of these products in large lots before moving on to the next one, there is a way in which you can take advantage of concepts like takt time and high junker to make these products in a mixed manner rather than completing one lot of one product first. You can make each of these different products in sequence of smaller lots. We'll look at an example to really understand these concepts a little better. The next process consideration is what is called standardized components and work methods. Again, standardizing components and standardizing the way work is being done reduces the possibilities of errors that can be in the system, and hence the likelihood of improving the system and making it lean increases. This is an example of mixed model schedule. Let's suppose that Toyota needs 200 Camrys, 150 Avalons, and 100 Venzas per shift to satisfy market demand. Now, what is the rate at which Toyota should make the products in a 8-hour shift? So 8-hour shift, we can first convert that into minutes, because typically when we are calculating something like takt time, we are trying to go as close to the lowest possible time unit as possible. In this case, it will be minutes. So what we are going to do is take that 480 minutes, which is the 8-hour shift, and divide that by the total production that is done, which is the 200 Camrys plus 150 Avalons plus 100 Venzas, which turns out to be 450 of them. So this is 1.067 minutes. So in other words, Toyota is rolling out a vehicle every 1.067 minutes from their assembly line. Now, this is the rate which is what we call the takt time, and it captures the cycle time needed to match the rate of production with the rate of consumption. The next step would be to develop a mixed model schedule for these different types of models that Toyota intends to make. The production requirement, we could have completed that by basically making 200 Camrys followed by 150 Avalons and then 100 Venzas. That would be one way to do it. But in a mixed model schedule, what you would do is you would first look for what is the ratio in which one could make it. In other words, what is the ratio for production requirements here? And we notice that the production requirements are in the ratios of 4 Camrys, 3 Avalons, and 2 Venzas. This is by dividing all of them by 50. Therefore, the cycle time will have to repeat after every 9 times. So 4 Camrys will be made, then 2 Avalons and 2 Venzas. So this is total of 9. After that, again, 4 Camrys will be made. So it will repeat in every 9 products that has been made from the system. So 9 times 1.067, which is 9.6 minutes. In other words, after every 9.6 minutes, the cycle continues. And this has to happen for 50 times so that you can make 450 of these products, because 480 divided by 9.6 gives you 50. So you have to make these cycles or repeat these cycles for 50 times. So that's the way a mixed model schedule is structured. And that's something which helps in ensuring the system is lean. The next process consideration is flexible workforce. And here the idea is that you are cross-training workers so that they can do multiple things. So instead of specialization, here cross-training is important, and that flexibility allows them to do multiple tasks and also help the organization to ensure quality at source. Whenever there's a quality issue, others can actually come and help because they are aware of all these different types of processes that are part of the organization. The next process consideration in lean systems is automation. Again, automation helps in lean systems, but once again, one has to keep in mind that this is not really implying that one has to go overboard on automation. There is a certain level of automation that is necessary to be able to ensure lean systems. Yet many of the tasks are still necessarily better done by human resources, because the idea of cross training and being able to manage different other process considerations require human intervention. The next process consideration is total preventive maintenance. And this refers to the idea that it's also called total productive maintenance, so that the machines that are in place, they are preventatively maintained rather than having to be fixed when they fail. And by doing so, you ensure that the flow rate is consistently maintained, because since the lean system works so close to the demand rate, the production rate and demand rate are so close to each other that any failure in machines can disrupt that entire system. There's no inventory buffer that you carry here. Hence, total preventive maintenance actually is very important for ensuring lean systems can operate effectively. The next process consideration is 5S. Essentially, 5S refers to these five terms that all start with S. Actually, in a Japanese, these are all coming from a Japanese language where this 5S also, each of them start with S. But the corresponding terms in English would be sort, which is to separate needed items from unneeded items. This could be including tools, parts, materials, and paperwork. It's a way to organize the system. So the whole 5S idea is about how we can organize this workplace so that everything is well done, systematically kept in place, clean. So sort is essentially to separate needed items from unneeded items. The second is straighten, which is neatly arrange what is left with a place for everything and everything in its place. In other words, organize the work area. The third is shine, which is clean and wash the work area and make it clean or shine. The fourth one is standardize, establish schedules and methods of performing the cleaning and sorting activity. You formalize that cleanliness, and therefore this helps the first three S practices to continuously being done, and therefore perpetual cleanliness and state of readiness is maintained. And the fifth term is sustain, that is to create discipline to perform the first four S practices. So you can continuously keep repeating these different things as part of your culture. Now, Toyota production system always comes in discussion whenever we talk about lean systems, because a lot of the concepts that we use in lean systems originated within Toyota production system when Taichi Ono and Tokoda together came up with this idea of creating a system which can then help in achieving the requirements of a lean system. So within Toyota production system, the idea is that all work must be completely specified as to the content, sequence, timing, and outcome. So there should be no ambiguity in terms of the actual work that has to be done. The second is all customer supplier connections. Now, this could be internal customer supplier connections between departments, for example, or external customer supplier connections, which is company to company connections. These are all something that Toyota production system expects to be direct and unambiguous. Again, the first one was an unambiguous understanding of the work content, work sequence, work timing, and outcome. The second is unambiguous understanding of customer supplier connections. The third is all pathways should be simple and direct. So as we go from one step to the other, we want to make it as streamlined as possible, as simple and as direct, so that everybody knows who the customer is, who the supplier is, what process is being done by the previous step, what is to be expected. And then the fourth idea is all improvements should be made under the guidance of a teacher using the scientific method. And this teacher is at a level where the production is happening. It's not somebody at higher up in the overall hierarchy, but instead somebody who is also part of the production activities, but who knows the system quite well, has been engaged with that system for some time. So any improvement that needs to be made for the first, second, and third step should be something which should be made under the guidance of a teacher. And they use a scientific method where there's a hypothesis. So for some reason, if suppose the work content or sequence or timing is not working, then there has to be a hypothesis of what is the other kind of approach that has been suggested. And then one needs to use that hypothesis and then test it in different conditions under the guidance of somebody who has been involved with this production system for some time. And then if that results in a favorable outcome, then that becomes part of the system. So this continuous improvement culture is essentially ingrained within Toyota production system. And that's one of the reasons that even after many people having understood this system, having visited manufacturing plants in different countries, Toyota's manufacturing plants, it's not that easy to um, replicate the system within the organization, because there's a cultural change that is required to really implement this production system. Pictorially, it is something which was presented as House of Toyota by Taichi Ono and Tokoda, where just in time on the left hand side and Jidoka on the right hand side are two pillars that support highest quality, lowest cost, shortest lead time by eliminating wasted time and activity. In just in time, you have ideas of takt time, one piece flow, and pull system, the kinds of process considerations that we just talked about. In Jidoka, we have concepts of manual or automatic line stop, separate operator and machine activities, error proofing, visual control. Again, some of the process considerations we referred to some time back. And together, just in time and Jidoka are creating a culture of continuous improvement. And then you need a foundation of operational stability that is achieved by Hygienka, by standard work, by total preventive maintenance, and by having supply chain coordination. So again, many of these things were part of the considerations that we talked about as the discussion of the lean systems. So overall, in this presentation, I highlighted some of the process considerations for lean systems, how they operate, and then we looked at what Toyota production system is and what are the foundational aspects of Toyota production systems. Thank you.